Hello. Hello.
Yes,
Yeah, am I audible?
yes, sir, you're audible.
Okay, thank you.
Good evening, sir. Sir, we will wait for 5 minutes, then we'll start.
Good evening, all. A warm welcome to all of you to this talk section organized by IEEE Fisat SB. I'm Sweda, and I'm honored to be a host for the night. Together, let's embark on a journey of inspiration and empowerment. As Cato the Elder said, grasp a subject, the words will follow. It's my privilege to welcome you all to this talk section on Introduction to EV and its. It's my pleasure to extend a warm welcome to our esteemed speaker of the day, Professor Venugopalan Kurupatth. I also extend a heartfelt welcome to all the attendees joining us for this insightful discussion. Your participation is greatly appreciated, and I kindly request you all to stay with us throughout the section, including the virtual photo section at the end. Let's make the most out of this opportunity to learn and grow. Without further delay, let's commence the section. With his profound experience and specialization in embedded systems, power electronics, and renewable energy, Professor Venugopalan Sir has been instrumental in driving innovation spirit among youth. He is also currently working as a professor in Muthu Institute of Technology. Sir, I welcome you to share your valuable insights with us.
Thank you, Sweta. So a warm good evening to all present here. Okay, and I would also like to thank the organizers of this meet. It's a very apt topic. I hope I'm audible. If there are any
Yes, sir, you're audible.
yes, yeah. So I would once again thank all of you for taking time. Because today it's a holiday, so I can see there are quite a large number of turnout, 42 to be exact. Okay, so I would I'll try my best to deliver something. Okay, so as Ms. Sweta told all of you that I have worked in power electronics, drives, and even done some work on renewable energy, signal processing, and all kind of electrical fields. Okay, and I have also worked in renewable energy with some work on electric vehicles. Okay, so I have done one retrofitting of a Volvo car in a university in Sweden. So I have some little experience in doing work in electric vehicles, and when I see the interest in electric vehicles among the youth and also among the electrical fraternity, I'm very enthused about this interest, and I feel there are a few basics that you should talk about. There are a lot of material available in the net regarding the technical aspects. Okay, so whenever we talk about electric vehicles, hybrid vehicles, and those kind of topics, the nitty gritty, the technical aspects of it, they're available in the net. Okay, all kinds of designs, technical specifications, how to do it, and all these are available in the net. So what is lost actually is the big picture. Okay, so whenever you take a course in electric vehicles or hybrid electric vehicle design, uh, they usually talk about how to design a vehicle, how is the motor selected, how is the drive selected, how is the propulsion selected, and all that. Okay, so the question of why, whenever we talk in engineering, we always encourage people to ask why. Okay, so but the why is never asked. Okay, so I think as an introduction to with the question why, make a transition from a well-established fossil fuel-based transportation to an electric transportation. What is necessary in this transition? Is it really necessary to do it on an in an Indian context? Is it really beneficial to us? What is it in for us as a developing nation with very scarce resources? Is it really in our interest to make this transition, or is there a hype being created about electric and hybrid vehicles? Okay, so those are the questions that we should all ask before and how it is to be made and all that. Okay, so that is one aspect that I find is mostly missing whenever we talk about electric and hybrid vehicles. Okay, so I will start with that question. So I find, can I present a screen? Hello.
Yes, sir, you can.
Yes,
Yeah, yeah, yeah. So I still am not able to. Do you have to give permissions to me to present my screen?
So
Yeah,
please wait.
1 minute. Huh? Let me try once more. Yeah, yeah. Let me see that. Okay. Okay. So let me start. And please feel free to stop me and ask any questions in the middle. Okay, it's not like we are all from the IEEE fraternity, so I'm sure you will have a lot of opinions about what I'm going to talk about, and please feel free to interrupt in between if you have to make any comments or clarify something. Okay, so are you able to see my screen?
Yes, sir. Yes, sir, we can see.
Can you see the screen? Yeah. So let's start with an introduction, a basic introduction. Thank you, thank you, thank you. Okay, so you can see three vehicles here on the top, and this is a plug-in electric vehicle. The Toyota Prius is a plug-in electric vehicle. City is a hybrid electric vehicle, and Nexon is a hybrid electric vehicle. Okay, so this is what is a pure electric vehicle. These things are a combination of IC engine and electric motors. Okay, but the term electric vehicle is used very loosely. It encompasses all these three types. So electric vehicles they have an IC engine as well. They come under the classification of hybrid electric vehicle. Fine. So that is what we start with, the basic classification. Okay. So when we look at the history of electric vehicles, we find that there is nothing. It is nothing new. And all this sudden hype about electric vehicles, examples here, you have electric vehicles here, which have already reached 60 miles per hour or 100 after some time less powers inferior compared to the electric at that time in 18 in those times. Okay, so we find the electric vehicles were preferred over IC engines, at least from this state, we went into IC engines. And what is the reason? Is there any change in the technology that prompts the industry to bring back electric vehicles? So that is what we should look at first. Okay, so when the first electric vehicles were produced, the major hurdle in its use was the battery. Okay, so batteries are energy storage devices, and we find that the battery technology at that time was very inferior, and it could hardly provide enough range for a normal use of an automobile. So that was a major reason why we could not use electric vehicles extensively, especially in America, where the distance between the cities was very large, and you had to commute large distances to travel from one city to the other. You could not use electric vehicles because the range of the batteries could not make that travel. So slowly we found the IC engines became more reliable. We find they became more reliable, and the IC engine slowly took over, and the electric vehicles totally vanished. So this was the stage. This was the reason why the start in electric vehicles, at least 1.5 centuries back, battery technology. The battery technology not keeping pace with the requirements of those vehicles. So it is nothing new. All the technologies that are used, the motors, the drives, everything was there, and they were very high performance vehicles at that time, which could reach 100 kilometers per hour, and that is what we have even today. Okay, if you look at all these vehicles in the present day, 100, 150 is the range that they still. So it is nothing new. Okay. Now, when we look at electric vehicles, when we look at the hype in electric vehicles, we have to look at what is the energy requirement, and what is the energy coming from. Okay, fuel, petrol, diesel, CNG, LPG, and other things. Okay, so you have a well-known fossil fuel. The way it is taken as a crude oil, the way it is refined, is transported to various petrol pumps, and the way you get it. Okay, so that path is well known. And when it comes to electricity, we also know that how the electricity is produced in various countries, especially India. If you look at the electricity production, we know that 70-75% of the electricity is from coal. Okay, so we have an energy mix. The electricity that is supposed to drive the electric vehicle, it is coming, which is 70-75% coal driven. Okay, so in many countries, the electricity is produced from predominantly produced from hydroelectric. It is nuclear in some countries. Okay, but most of the big economies of coal-based thermal power plants. Okay, so what is known as a thermal power plant. If you look at the Indian state, then you can see that in 2021 there is a slide which shows life cycle greenhouse emissions. Okay, grams of CO2 per kilometer. Okay, so on the y-axis we have grams of CO2 emitted per kilometer. Okay, for an IC engine, it comes to around 250. Okay, so it comes 250 grams of CO2 per kilometer for India. Okay, if you look at the neighboring country China, you will find that it is slightly above the Indian emission. Okay, it's slightly above the Indian emission. So when we look at the battery electric vehicles, okay, you find that the upper end of the battery electric vehicle. Battery electric vehicles are promoted as zero emission vehicles. If you read the ads very carefully, if you read what the companies say very carefully, you will find that they always write zero tailpipe emission. Okay, they don't say that the vehicle per se is zero emission. They always say that the vehicle is zero tailpipe emission. Okay, but if you look at the whole life cycle, okay, because that is what actually matters. It is not the only the emissions that matter are not only what it emits while it is running, but in the whole life cycle of that vehicle. If you look at
So,
the, yeah, pardon.
so it's still the first slide. It's not
Oh,
changing.
okay. One minute, huh? Let me. Okay. Has it changed? Is it
And
changing now?
sir,
No.
no, sir, it's
Pardon?
not changing. And sir, your sound is lagging also.
Okay. Let me. Is anybody's video on? If you can ask some people to.
The video is on, but it's still the first slide.
Okay, 1 minute. Huh? 1 minute. Let me take a look. Okay.
So now we can see the graph.
Yeah. Thank you. So I think let me try again. Is it okay now? Hello.
So the screen
No,
is not shared.
Okay. Right. It is not shared. Okay. I think there is some problem with the. Okay. Window. Yes. Shared. Yeah. Is it okay now?
Yeah, sir. Now it's
that's right.
okay.
Is my voice breaking? Are you able to make out what I'm talking? Or
No, sir, now it is
Sir.
clear.
Now it's fine.
okay, fine. Thank you. So I was talking about this graph. I was talking about this graph from India, where we see a comparison of IC engine vehicles and battery electric vehicles, and then we find that the IC engine vehicles have a total life cycle GHG emission, greenhouse gas emission of around 250 grams of CO2 per kilometer. Okay, so the per kilometer of its travel, if you start from the life of that vehicle to the time when you scrap it, okay, everything included, the whole life cycle of that vehicle, if you calculate the CO2 emissions per kilometer, it comes to around 225 to 250. Okay, so that is what we see here. All right. And if you compare that to the battery electric vehicle, which is the purest form of electric vehicle, then you find that it is around 175 to 180. Okay, so surprisingly, when these companies promote electric vehicles, and when we are told very enthusiastically that we should all adopt electric vehicles, I'm not saying that it is not to be done, but we should always keep this picture in mind. Okay, so we should always remember that the IC engine vehicles have around 220 grams of CO2, and the electric vehicles have very near with some around 170 to 180 grams of CO2. Okay, so that is a picture that we should look at first. Okay, now why is this picture important, and how does it compare with Europe? If you take a look at Europe here, we find that the IC engine vehicles are more or less the same in their emission. We can find they are very close to 250 as we have in India. Actually, the Indian IC engines emit slightly lower grams of CO2. But if you look at their electric vehicles, we find that it is around 80. Okay, so that is the difference. So when we say that electric vehicles are good, it is not equal every country. Okay, that is one thing that we should remember. When we look at Europe, the electric vehicles emit very low. They have very low emissions in its lifetime, at least one third or one fourth of what we have in India. So, what is the reason behind this? And when it's not very difficult to understand the reason. The reason behind this is because our electricity is 70%, 75% from coal. We are coal dependent on thermal power plants, whereas many of these European countries, especially the Scandinavian belt, is having lots of renewables and hydroelectric. So it all boils down to how we make electricity. Now, if I'm going to get all the energy for transportation from electric grid, then what matters is how that electricity is being generated. So that is what is to be really understood first before claiming benefits from electric vehicles. So please don't take it that I am pessimistic about the future of electric transportation. I'm just trying to present an unbiased picture uh, such that we should all understand what we are getting into. Okay, so let me go to the next slide. Please tell me if it is changed. Uh, has the slide changed? Now I'm having
Yes,
IC
sir.
engine and fossil fuel based. It is okay, is it not? Okay, thank you. So now we look at what is actually the efficiency in IC engines and fossil fuel based EV charging. So EV charging mostly in India is done from fossil fuel based thermal plants. Okay, so if you look at this chart, we'll find that on the left you have the IC engine vehicle. Okay, and then on the right you have the electric vehicle, and we find that both of them start from crude oil. In the case of India, it is not crude oil, but it is coal, and more or less the graph is more or less the same. Okay, so in the IC engine case, you start from crude oil, and then we find that the overall efficiency on different stages. Okay, crude oil coming to refinery, refinery going to the distribution tank, then going to the petrol pump, and then coming to the engine, and then going through the engine to the wheels. Okay, so you find that the efficiency, the net efficiency when it reaches the wheel of the vehicle is around 19 to 15%. Okay, so there have been improvements in efficiency. This has gone up to 22, 23% now. Okay, so but more or less this chart conveys the basics of electric and IC engines. Okay, so in the EV side, you come from coal instead of crude oil. You can read it as coal, and then you go to the thermal electricity generation. By the time the efficiency has dropped to 40%. Okay, and when it goes through the transmission and distribution network, then it reaches the battery charger and the battery and finally when it reaches the wheel, then you find that the efficiency is between 20 to 14%. So when you look at these efficiencies in terms of energy, okay, not in terms of emissions. In the last slide, we saw what is the emission comparison, and this is the efficiency comparison between the energies. Okay, how efficient is electric vehicle and how efficient is the IC engine. So the IC engine turns out to be an overall 19 to 15% efficient. The electric vehicle turns out to be 20 to 14% efficient. Okay, maybe the electric vehicles with the coal, when we have coal here instead of crude oil, it might go up to 28, 30%. So, but still, you will find that it is not a big difference between the efficiencies of electric vehicles and IC engines. Okay, so having seen the emission comparison, having seen the efficiency comparison, now I think we should ask ourselves why is the industry promoting electric vehicles in such a big manner, and why are we all being encouraged to switch from IC engines to electric vehicles? So that is what we should all ponder about before we start looking at the details of electric vehicles and types of electric vehicles and implementation of electric vehicles. Okay, so that this is the picture that all of us should be looking at. So let me look at one more graph. I'm trying to show you all aspects of comparison between the electric and
So,
gasoline.
still the blue graph.
It is still on the blue graph.
Yeah, it's still on the blue graph.
Okay, I don't know. 1 minute. Huh? Uh, is it changing now? Has it changed? It's not
Yeah,
on
it has
a.
been IC engine and fossil fuel comparison.
So maybe I can just leave it like this and may not have the full view. Maybe I can do it like this. And if I change it now, is it changing? I am changing it
Yeah,
now.
so, so it's changing now.
Okay, okay. So I think I will leave it now. I'll leave it like this now, because if I put it in slideshow, I think it's not changing. I don't know. I don't know the exact
No,
reason why.
this is fine.
Okay, thank you. So this is what I was trying to talk about. I think you only heard my audio, and you didn't get to see the figures. So what I was trying to talk, I'll quickly restate what I was trying to say. So I was trying to compare the energy efficiencies between the IC engines and the electric vehicles. And then you can see the IC engines when they start from the crude oil stage, and then when they reach the wheel of the vehicle, they have an efficiency, energy efficiency going from 19 to 15%. So that is these figures are at least 15, 20 years old. So there have been minor improvements in this. So it might go up to 20, 25% now on the upper side. Okay. So here on the electric vehicles, again starting from fossil fuel, instead of crude oil, you can read it in the Indian context as coal, and then you can find that the energy efficiency, overall efficiency, is going from 20, 25% to 15, 20%. So on one side you have 20% here and you have another 20% there. Nothing much to choose from if you look at the overall energy efficiency. Okay, you take some fuel, and then you measure how much of that calorific value has reached the wheel. Then we find that more or less the IC engines and the electric vehicles have more or less comparable efficiencies. Okay, but please note in this electric vehicle journey that we show here, the energy starts from the fossil fuel, and then it ends up as a tractive effort on the wheel. Okay, if I go from if I don't have fossil fuel as my energy starting point, if I have renewable energies in the form of electric energy as my starting point, then this efficiency will go up to 70, 75%. Okay, so that is a factor that we have to keep in mind. And what we can conclude right now from this figure is that instead of fossil fuel based electric energy generation, if I can have renewable energy generation, these figures become very attractive. Okay, because this final efficiency will become 70, 75%. and then the electric vehicles really have an advantage. Amount of energy being produced from renewable energy, we don't get the kind of efficiency improvements told is available in electric vehicle technology. Okay, so that is what we all have to keep in mind. So we should convert our energy generation, and then we will have the maximum benefits of converting from IC engines to electric vehicles. So that is what this chart conveys. Okay, so has it changed now? I'm now showing a slide where we have energy used by
Yes, sir.
information, please. Hello.
Yes, sir.
Yes, sir, we can see.
This chart is showing energy used by IC engines and electric vehicles at various speeds. Okay, so you can see that as the speed increases, okay, so the energy used is megajoules per kilometer. So at low speeds, the battery car has very good advantage because the IC engines are not very efficient at very low speeds. Okay, so we find that at very low speeds, the battery car consumes very less energy, but as the speeds and the battery car energy consumption more or less catches up. Okay, so what this graph tells you is that driving at very low speeds, and those the gasoline cars don't have
Sir, your voice is breaking.
traffic and heavy traffics in the city. So at those conditions, the battery car is very efficient. But as a find that the gasoline car and the battery car, the energy consumed, the megajoules per kilometer, that consumption catches up. Okay, so if you are going in for an electric car, you get maximum advantage over the gasoline vehicle if you are predominantly running at medium to low speeds. So that is what this slide tries to convey. Okay, I hope you can see that slide. Hello.
Yes, sir, we can.
So we
Hello, sir.
the next slide we go to the mind to wheel efficiency. Okay, so this is what we already seen in a chart. So I think we'll just skip this. Okay. So from the generation to the transmission, we have a loss of if you look at the IC engine vehicles at the bottom, we find that from the refinery to the petrol pump, we have 80% of the energy, okay, retained when it is at the petrol.
Excuse me, sir. Your voice is breaking.
I will do one thing. Please let me stop sharing, and I will try to connect it to another network. Okay, so I will please give me 5 minutes. Huh? Okay.
ഗൈസ് ആരും പോകരുത്, സാർ ഇപ്പൊ തന്നെ വരൂ കേട്ടോ.
Hello.
Yes, sir. Hello, sir.
Yeah, can you hear me now?
Yes, sir, we can hear you.
Is it any better? I joined a new network now. Is it any better now?
No, sir, it's just cut.
Hello? Is it still breaking?
So it's okay. Sometimes breaking, but it's better now.
It's better now. Okay. Let's try. I mean, that is that is all I can. I have changed
It's okay, sir. I
one
got it.
network to the other network. Okay. I hope it will be okay. Okay. So
Okay, sir.
please interrupt me when it is not okay. Okay. Yeah. So let me start again. Okay. So I'll try to rush through because can you see the slide?
No, sir, it's not.
Uh, Not visible. Okay. Okay. I don't know. I mean, I'm at home. I don't know. Maybe the network here is really bad. Yeah.
Yes, sir,
Pardon?
it's visible for a minute and then disappear.
Then disappeared. Okay. 1 minute. I'll try it once more. Yeah. 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 Can you see it now?
Yes,
I
sir, we
think
can
it
see.
should be.
Now it's
Yeah. Okay. Okay. Is my voice okay? I mean, not very good, but is it still okay?
no, sir, now it's okay. It's clear.
Yeah, fine. Okay, thank you. So we'll take a quick look at this. So what this slide tries to convey is that if you start from 100% of energy, and by the time it reaches the charging point of an electric vehicle, the energy has dropped. Okay, and then it drops to 23% by the time you go to the wheels. And when you take a look at the same situation in IC engines, we start from 100% and 80% is available at the pump. And due to the very inefficient IC engine available in the vehicle, that conversion is very inefficient. So the 80% drops to 13% to 16% on the wheel. So 23% on the electric vehicle and 16 to 13% of the IC engine vehicle. That is all is actual difference when you try to look at the energy efficiency of the electric vehicle, the whole energy efficiency, not of the vehicle alone, but from the generation to the wheel and from the crude oil to the wheel of the in both the cases. So that is the comparison that we have in terms of energy. Okay, so we don't have very big differences of magnitude of 2 or 3 in the case of IC engines and electric vehicles. So that is what we should look at. Okay, so this I think we can skip because we don't have time now. So if you look at EV adoption, okay, so whenever we look at EVs and the hype created in EVs, we should always see how the EV is growing in terms of the total vehicles. Okay, so the electric vehicle adoption, you should, if you look at it, the numbers look impressive. It is 270 lakh or 27 million global electric fleet. We can find it globally. You have around 27 million. And if you look at the Indian scenario, we find that it is around 6.3 million. Okay, so you not 6.3 million. We have around 13 lakh 79,000 electric vehicles in 23. Okay, so the latest figures is 13 lakh, 6.3% share in the vehicles. And out of that, if you look at the four wheelers, we find that the four wheelers are really, really small. This small light green in this slide is what is a four wheeler. So four wheelers are very, very small compared to the total electric vehicles, and a big chunk of it is made up of two wheelers and three wheelers. So if you look at the Indian scenario, whenever we look at numbers of electric vehicles, we have to remember that a major chunk, around 80 to 90% of it, is made of two wheelers and three wheelers, and very small percentage of the electric vehicles sold in India are actually the four wheelers. Okay, but globally, two wheelers percentage is very low, and most of the electric vehicles sold in other countries, in developed countries, they are all four wheelers. Okay, so that is one thing. And the Indian scenario, you can see the growth of EV market in India going from 15 to 20. We can find a good curve of growth. Okay, so we can see the number of vehicles registered and what is the percentage market share of electric vehicles. So in 2020, it was reaching around 1%. Okay, 1% of the total electric vehicles. And globally, if you look at it, China is reaching around 14 to 16%, and all the other countries are listed here. So they have we are somewhere around 1%, and they are around 16%, and lower. Okay, so if you take Europe, it is around 10%. If you take US, it is around US is also around 7 to 8%. So we have different countries having different adoption rates of electric vehicles, and we should remember most of these electric vehicles are all four wheelers. Okay, whereas what we see in India is predominantly two and three wheelers. Okay, that is not to get discouraged about. Slowly and steadily, we are also adopting electric vehicles, and we will in the future, in the near future, we will see an growth or explosion of four wheelers because the technology is improving, the efficiencies are improving, and more R&D and investments are taking place in electric vehicles. So the Indian scenario, even though right now it looks a little discouraging, it is going to grow rapidly, and we are going to catch up with these numbers of the other countries. Okay. So how now? If we have already seen, I already tried to present what is the energy used. Okay, so this figure, if I can come back to this figure, what it shows is at very low speeds. Okay, the battery electric vehicles have a huge advantage because they use very low energy. Okay, and as the speed increases, the difference in energy used by the gasoline car and the electric battery car is reducing. The gap is reducing. Okay, so when we look at modern in that context, if I look at the modern modified Indian driving cycle or the driving conditions in India, then we find that the urban driving cycle is mostly very low speed or medium speed. You can find it is a graph which goes from 10 kilometers per hour to 50 kilometers per hour. Most of this graph you can see the speeds attained, the peak speeds attained are all 50 kilometers per hour. And when it reaches to extended extra urban driving cycle, where you reach some highways, the speeds go up to 80 to 90 kilometers per hour. So what this tells me is that the electric vehicle is most suited for urban driving cycle because the speeds are low, and at low speeds the battery electric vehicles or the electric vehicles have a huge advantage compared to the IC engine. So this is one chart that we should all remember, because then when we have to choose a vehicle, it depends on what kind of driving cycle you are going to have. So, what is the type of driving cycle that the vehicle is going to encounter? Depending on that, you will find a large difference in efficiency between the electric vehicle and the IC engine. So, if you are in a city, if you are keeping low speeds, if you are encountering very start and stop traffic, then we find that the electric vehicles are the most advantageous. It is at the best in these conditions. If you are doing very high speed highway runs, then the advantage that we have is not so much. So that is what this curve tells you. Okay, so I'm trying to put the use of electric vehicles and IC engines in a proper perspective, and look at all the angles before going into the technical specifics of an electric or hybrid vehicle. Okay, so when we look at the storage technologies in an electric vehicle, we have three main components. One is the battery, the other is the power electronics converters and inverters in the electric vehicle, and then you have the electric motor. Okay, so the electric motor is a well-known technology. There are a few types of motors that have come recently. We have brushless DC motors, we have switch reluctance motors, we have permanent magnet synchronous motors, and different type of motors there. But motor technology and is well understood and well proven. So what is when we have seen the history of electric vehicles, we have seen that what held the electric vehicle back was the battery technology. Okay, power electronics has also grown. Initially, we didn't have this kind of power electronics and control capabilities. Now, the control and power electronic areas are well proven and well established. So, what is remaining to be improved upon is the battery technology. So, we have a chart for batteries and different kind of electric energy storage. Okay, so we can see lead acid batteries having a density of 100 kilojoules per kilogram, okay, or 30 watt hours per kilogram, which is very low compared to the fossil fuel energy density. Then we have lithium batteries, six times better, but still lower, still very low. Compressed air and other ultra capacitors and other type of electric storage are very low. And at the bottom, you can see the gasoline energy density, that is something around 43,000 kilojoules per kilogram. So, okay, when we talk about the storage of energy, 1 kilogram of gasoline has a calorific value of 43,000 kilojoules, and 1 kilogram of lithium ion battery can store only 600 kilojoules. So that is the kind of comparison we are making when we talk about the energy density between the batteries and gasoline. Okay, but one thing that we should remember is 600 kilojoules of lithium-ion battery will be converted into the actual tractive power at the wheel with an efficiency of 70 to 80%. So 80% of 600 kilojoules will be available at the wheel from the battery, whereas 43,000 kilojoules when it reaches the wheel, it will be only around 30% or 20% of this. So there is a big efficiency difference between the power conversion from the battery to the wheel and from the fuel tank to the wheel. So that is always there. But the energy density between the batteries and the gasoline is very wide, and this is something that is holding up widespread adoption of electric vehicles. Okay, so here we have another chart which tries to convey what is the kind of energy that is being converted. So if you have 100% of energy in the fuel tank, by the time it reaches, in the IC engine case, by the time it reaches the wheel, it is 13%. We already seen this in the previous slides. And out of that 13%, we can find that aerodynamic drag or the air resistance takes out 3%, rolling resistance of the wheels is 4%, and the braking effort takes 6%. So you will find that on an average, from 100% from the fuel tank, by the time it reaches the drive line, it is 16%, and from the drive line you have some losses, and by the time it reaches the wheel, it is 13%. Okay, so this is the conventional IC engine energy transfer from the fuel tank to the wheel. So here we look at what is happening in the electric vehicle. So we have energy, some energy in the batteries, and 76% of that is available at the wheel. Okay, so whatever energy we have in the battery, the motor is having 90% efficiency. The drive line, including the differentials and the drive shafts and everything else, is having 90% efficiency. The battery is having 76%. Okay, so
Sir, your mic is mute.
okay. When was it muted? Just now or?
Just now.
Okay, fine, fine. Okay, let me. Okay, so I was talking about this electric vehicle efficiency. Previous slide, I talked about the IC engine efficiency, and here this slide tells me that from the battery to the wheel, 76% of the battery energy is available at the wheel. So the losses in the transmission and in the conversion are very low, whereas in the IC engine we find from 100 to 13%. Okay, so you have a major loss of energy in the engine, IC engine, and the drive line. So that is a comparison between the electric vehicle and the IC engine vehicle. Okay, so when we, I think I can skip this and go to the classifications of electric vehicles. So now let us, now we have seen in all the previous slides, I have seen, I've been telling about why we should go for electric vehicles, what is the kind of comparison we should look at. So all these previous slides, we should look at it carefully before we land up into the classifications and specifics of hybrid and electric vehicles. Okay, so definition of electric vehicle is a vehicle which is basically having an electric motor instead of a conventional IC engine. Okay, so any vehicle which has an electric motor providing tractive effort, okay, or the power to move the vehicle, that is classified as an electric vehicle. Okay, and the types of electric vehicles, that is a general classification, and under that classification we can have battery electric vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, and fuel cell electric vehicles. So you can have four different classifications under electric vehicles. So you can see electric battery electric vehicles is what is the most promising, and all these Indian vehicles that we see on the road are all more or less all of them are battery electric vehicles. We have a few hybrid electric vehicles, but the kind of electric traction that is available in these vehicles is at the best a mild hybrid. Okay, we don't have very strong hybrid electric vehicles in India. So all the high riders and high cross and all those vehicles that we see on the Indian roads are all either micro or mild hybrids that are running around. Okay, so mostly the Indian market is tuned towards battery electric vehicles. I haven't come across any plug-in hybrid electrics in Indian context. Maybe a few imported ones are available, but none of the Indian manufacturers have come out with plug-in hybrid electric vehicles. And obviously, no fuel cell electric vehicles. Okay, so those things are not yet seen in the Indian road. We are seeing only battery electric vehicles and hybrid electric vehicles. Okay, so whenever vehicles we talk whenever we talk about the technicalities of vehicles and the design of vehicles. We talk about the basic vehicle model. So we always start when the design and the component selection is done. We always start with this kind of a vehicle model where different forces acting on the vehicle are analyzed. And I'll quickly introduce you to the most basic components of this vehicle dynamics. And then we find that when the vehicle is moving upward, okay, in this direction, we find the wind will be opposing. There will be a force due to the wind which will oppose the vehicle motion, and there is a mass of the vehicle which will be acting, and then that mass will have a component mg sine alpha. The alpha is the inclination of the road. The vehicle is having a upward inclination, and that upward inclination will have a gravitational component which will be pulling the vehicle down. So we can see one force component here. Okay, then there'll be a rolling resistance of the tires on the road. So you will have, because it's all rubber tires rolling on the road, we will have certain tire resistance components also. So basically, these are the components that we take, and then there'll be an acceleration component. When the vehicle is accelerating, we know that mass into acceleration is a force. So that acceleration component will be there when the vehicle accelerates, and the wind component opposing the vehicle movement, the rolling resistance opposing the vehicle movement, the inclination having its own component, the gravitational component due to the inclination. All these are the major components that we consider when we take a vehicle and analyze its dynamics and try to come up with various ranges of batteries and motor specifications and other things. Okay, it can be in the case of an electric vehicle, it can be in the case of a hybrid electric vehicle or an IC engine. In any type of vehicles, this is where we start. Okay, so you will find if you have to do any design or go deep into the electric vehicles, this is where we start. Okay, so now let me try to come into some tractive effort basics of electric vehicles and IC engines. Okay, so the graph that is shown here, okay, this graph that I'm trying to trace with my mouse pointer, that is a graph of the vehicle with gears. Okay, so if you take a practical vehicle and then try to see what is the tractive effort required with respect to the vehicle speed. Okay, as the vehicle speed is shown on the x-axis, kilometers per hour, and the tractive effort in kilonewtons, we find that for a normal operation of a vehicle, this is the envelope of the tractive effort versus vehicle speed. So that is what is required. Okay, so in a conventional geared engine, geared engine is having a definite speed range, maybe going from 700 rpm to 6000 or 7000 rpm. So that is the kind of range that is available, and then that is converted into the vehicle speed. So that first gear will provide some range of speed but very high torque, a very limited speed of range but very high torque. You go to second gear, the torque has come down but the speed range is increased. So that is how a geared IC engine vehicle manages to go on this curve, okay, this envelope. So whatever is required for a normal drive in an IC engine vehicle is managed with the help of gears. If you have an automatic transmission, then either a CVT or a torque converter, then some kind of manipulation is done to follow this curve. Okay, so you have some internal mechanisms such that this curve is followed. Okay, now if I look at the electric motor, either irrespective of what kind of motor we have, the gears will be followed. basically to have this kind of this dark the bold single gear motors inherently are are designed for a tractive effort in vehicles. Okay, so we can see that whatever tractive effort between tractive effort and vehicle speed is required we know that the electric motors are even without many gears with only a is very encouraging first aspect of electric traction. Okay, how many more minutes can I have? Do I have to stop now, or I think it's 1 hour? But if you can give me 5-10 minutes more, I can. Hello.
Yes, you can take 5 more minutes.
Thank you very much. Okay, so this is the IC engine versus electric drive comparison. Okay, you can take a look at the constant torque region and constant power region here. So in the constant power region, the torque will fall, but that is okay because the vehicle demands that kind of a characteristic. So that we have seen in the previous curve. Okay, so this is a typical torque profile of a 60 kilowatt electric motor. So you can find the 60 kilowatt electric motor has a torque curve that is very apt for a vehicle application. Okay, so you can find with different gears, you can incorporate different gears into this torque speed characteristic, and then you can have this. Different gear-like transitions you can have, and you can cover the entire vehicle operation within one motor characteristic. Okay, so I won't go into any details of it. Okay, so this is a typical EV where we have a battery pack, we have a external any onboard charger where we will connect to the grid, and then we have an inverter which will convert this DC power from the battery through an inverter. It will be given to an electric machine, because most of the motors, even if it is a BLDC brushless DC motor or a permanent magnet synchronous motor or a switch reluctance motor, all of them require an inverter. Okay, so even if it is a brushless DC, the brushless DC still requires an inverter. So we have a battery pack, a high voltage battery pack, a large battery pack here. Then we have an inverter here, and that is driving the traction motor, and that is connected to the wheels. Okay, either a front wheel or a back wheel or all the wheels. Okay, and then we have a DC-DC converter which is connected to a 12-volt battery for auxiliary power in a vehicle. So this is the kind of layout that you see in electric vehicles. Okay. So when it comes to hybrid configurations, we find that there are two main classifications of hybrid. One is a series hybrid, and the other is a parallel hybrid. So the series hybrid is something that you will see in the near future, because one of the main manufacturers in Indian context, Maruti Suzuki. Okay, they have announced that they will be coming out with series hybrid in their Swift and other small hatchback models. Okay, so they are coming out with a series hybrid where you have an internal combustion engine driving a generator. So you can find the internal combustion engine here and the generator coupled to that engine. Okay, and that generator will produce electric energy, and that electric energy will drive the traction motor, and traction motor is what will drive the wheels. So we find that the IC engine mechanically has no connection to the wheel in a series hybrid. The energy from the IC engine is converted into electrical energy by the generator, and the electrical energy is converted into mechanical energy by the electric motor, and that mechanical energy is driving the wheels. Okay, so there are many stages of conversion here, from mechanical to electrical and electrical to mechanical, and then finally it is driving the wheel. So one might wonder why this kind of a hybrid could prove beneficial. Okay, the answer to that is because the IC engine is not directly connected to the wheel. This IC engine can operate at an RPM at which it will produce maximum fuel efficiency. Okay, so we have an IC engine which need not change its speed depending on the speed of the vehicle, because it's not mechanically coupled to the vehicle, and as a result of that, it provides electrical energy through the generator at its maximum efficiency. So we find that even if there are multiple stages of energy conversion here, the vehicle still provides excellent fuel efficiency. Okay, on this side, we will find there are parallel hybrids. These are some models that we find in the Indian market now. The Toyota Hyrider and the High Cross and all other kind of models that we find, they are all parallel hybrid. Okay, so we have an IC engine providing mechanical drive to the wheels, and we have a motor with its battery pack that is also connected mechanically to the wheel through some clutch mechanism. Okay, so both the IC engine and the electric motor, if required, can combine and drive the wheels. Okay, or the IC engine under light load of the vehicle, the IC engine can connect to the motor, which will act like a generator, and that can be used to charge the battery. So we can have a parallel hybrid, which is currently seen in the Indian market, which has lesser stages of conversion, which looks on paper to be more suitable as a hybrid. There are many types of parallel hybrids: IC engine dominant parallel hybrid, electric motor dominant parallel hybrids, and there are many combinations of series and parallel hybrids. So there are different configurations in the market, but basically we can configure them in two types: series and parallel hybrids. Okay, I think I will take 2 minutes more, and then I will stop. Okay, I still have a lot of slides, but I think I've run out of time. Okay, because we lost the network in the middle. I think we lost some time. Okay, so this is the final slide I will show. Please bear with me for another 2 minutes. Typical electric motor efficiency of an electric vehicle. So when we talk about motors in electric vehicles, this is a typical motor efficiency. Okay, this is nothing specific to any type of motor technology, but almost all the technologies that we use now can be brought to this kind of a curve. Okay, so whatever we find, these ISO curves that we find on this diagram, they are all efficiency curves. Okay, so what we should infer from this is, when you look at the high efficiency curve in the middle, 90%, what I've shown here, what it shows is under certain speed range, let me say 1500 to 1000, and under some torque range, 150 to 250 Newton meter. If I am operating in this particular torque range and this particular speed range, the motor has the best efficiency. Okay, so if I operate at very high speeds and at very low torques, then I have 60% efficiency. It can drop to 60, 70%. Okay, so the electric motors that we have, when they are operating in some areas, just like the IC engines, okay, the electric motors also have a preferred operating speed and operating torque. Okay, so that is what we try to understand from this slide. And even when we are designing drives for hybrid and electric vehicles, we should always keep this in mind and try to operate the vehicle for the maximum possible time in these kind of high efficiency areas. I think I have exceeded the time, so I think I'll stop now. Maybe if there are some questions, quickly I can take one or two questions. I'll stop with my presentation now. Thank you. Hmm?
Thank you, sir. Now it's time for question and answer section. So I
Yeah,
request the participants to clear any doubts they may have related to the topic.
yeah. See, what I have tried to do is there are many courses, textbooks, and other material available on the technical details of these vehicles. Okay, so what I have tried to present is because we are all IEEE members, we should have a bigger picture of this whole field before we go into the details. Okay, so what I try to concentrate in this talk is regarding the why of this whole technology and what is the Indian specific context of electric vehicles. There is a big petroleum lobby and automobile manufacturers group, okay, which is very influential and powerful, and they influence most of the policy decisions that we encounter in our government policies. Okay, not only in India. I'm not talking about India specific things. In the whole world, there is a big petroleum lobby and an automobile manufacturers lobby, which is invested in IC engines. Okay, so a lot of research and lot of material that we see is influenced by their policies. Okay, so whenever we see ads and other literature going one way or the other in a very positive or negative direction, it as technical people and as people who will make a lot of difference in the future of electric industry and vehicle industry, we should take an informed view on this by going beyond the hype that we see. Okay, so that is what I have been trying to convey. So if you want, I will share this uh, PowerPoint, and you can. I have a few links and all included in this, so you can look at those links, read a little more, um, and convince yourself regarding the facts of this field. Okay. Now I can take a few questions. Please feel free to ask.
So, do you believe the future is full EV or people will revert back to IC engines?
In my opinion, we are not, as I showed, the electric energy mix that we have is 78% coal based. Okay, so when we switch to electric vehicles, we don't really get the advantage of an electric vehicle because the electric energy still comes from thermal power plants, which are highly polluting. But when I say that, when we look at the vehicle density in city centers, if you go to big cities like Delhi or Bombay or even Cochin for that matter, in the city center, the vehicle density is very large and they cause considerable pollution. Okay, so when if a good percentage of those vehicles can be converted to electric vehicles, definitely the pollution in the city center will come down, but that extra electric energy required will cause extra emissions at some isolated thermal power plants. Okay, so in a way, it is good as a short-term effort because the city centers will become have better air quality. But definitely, that emissions don't go away because it will be transferred to some isolated location where we have huge thermal power plants. So the net emission may not drastically reduce, but the city centers will become definitely cleaner. So in that context, in that limited context, it is okay. I think people are going to look into hybrid vehicles in a short term. Uh, Hybrid vehicles are going to come up in large numbers because what ultimately motivates most of us when we have to shift to electric vehicles is the financial incentive. Okay, let's not pretend to be otherwise, because if the financial incentive was not there, uh, a large portion of the adoption of electric vehicles would not happen. Okay, so electric vehicles, as long as they are financially incentivized, people will go for electric vehicles. Uh, but will it really make the transportation green? That is another question. Okay, so the city centers will become cleaner, but as a whole, in the nation, if you look at it, it is not going to make it any cleaner. Uh, so I think in a short term, people, because of the range anxiety and the infrastructure of chargers and all being very poor, a lot of people would go for hybrid electric vehicles. And slowly and surely, in long term, I don't think there is any alternative other than to go to electric vehicles. Okay, but for that, our grid has to be strengthened, our charging infrastructure has to be strengthened. We have to find resources of lithium and other materials required to make batteries. We have to have rare earth mining and minerals for making rare earth magnets for our electric motors. Okay, so there are a lot of things to be developed. We have to have a recycling policy for batteries which have been used. So we have to do a lot of. We have a long way to go before we can become predominantly electric vehicle. Okay, so I think in the meantime, in a short term, people will try to make the best of this situation by going to hybrid electric vehicles, and then the next stage they will shift to electric vehicles. That is my reading about the situation here.
Thank you, sir.
Yep. Anybody else? Uh, how many of you are electrical? I think a good number could be electrical, and maybe a few of you are taking some electives in electric vehicles and other things. There are very good NPTEL materials. Okay, there are from IITs. There are very good materials, very prominent professors, in depth talking about electric vehicles. So that's why I chose not to go into technical details, because there are a lot of material by very prominent professors available on NPTEL. Uh, so the details are all there, but the larger picture of why we should go there, go to electric vehicles, is often not discussed at all. So I thought, as a IEEE chapter, this group at least should know what is the ground situation in India, Indian context, and in the global context. What is the situation and what are the real benefits of going to electric vehicles? Okay, so please keep yourself open. Look at all the aspects. Remove the hype from this. Look at all the aspects in a very practical manner, and take informed decisions when it comes to these kind of topics. Okay, any other questions? I think it being a holiday, I think I've been holding you for nearly 1.5 hours now. I'm sorry for the connectivity problems, because I'm not in the college, I'm at home. I think there is some problem with the bandwidth here. Okay.
Sorry, it's okay. I think there are no more questions.
Yeah.
So now, as we conclude our event, I would like to present the speaker with a token of gratitude by presenting the virtual memento.
Thank you.
And I request all the participants to kindly switch on the camera to take a snapshot of the section. Everyone, please turn on your camera.
Yeah, it's nice to see all of you. Mhm.
Thank you, guys. Let's take this opportunity to extend our gratitude to our speaker for the valuable contribution. First of all, on behalf of IEEE Fisat SB, we extend our heartfelt gratitude to you, sir. Thank you so much for your valuable efforts. Also, I take this opportunity to thank all the attendees for your presence and enthusiastic participation. Lastly, I thank all the volunteers for enabling the smooth conduction of the event. I hope you all had a good time. I request all participants to fill the feedback form before leaving this meeting.
Yeah,
So
please, please feel free to contact me. Send a mail. I have a lot of materials and MATLAB simulation files and things like that. If somebody is really interested in taking this forward, please feel free to contact us or mail.
yeah, sure,
Yeah,
sir. Thank you.
I'll extend
Uh,
all kind of help that I can. Okay, please do that. Thank you.
yeah, sure. Thank you, sir. So once again, thank you everyone for being a part of this meaningful celebration. Have a wonderful day. Thank you, sir.
Thank
Everyone can
you.
leave the meeting now. Just fill the feedback form.
Thank you. Thank you.